Russia's railway engineering industry, one of the nation's most vital industrial sectors, has released its official production figures for the first 3 quarters of 2025. Covering January through September, the data provides a thorough overview of the nation's rolling stock and locomotive manufacturing sector's performance amidst evolving logistical, economic, and geopolitical circumstances. Although the final annual data will not be published until early 2026, the existing figures already provide meaningful insights into locomotive output, freight car manufacturing, and the overall distribution between diesel and electric traction. The findings exemplify both resilience and transformation. Russia's rail manufacturing industry has largely recovered following the structural disruptions of 2022 and 2023, attaining production levels comparable to, and in some segments surpassing, pre-sanction standards. In particular, a focus on electric locomotives and the variety of freight cars reflects the realignment of cargo routes toward Asia, the Black Sea region, and domestic distribution corridors. The figures further highlight the ongoing advancement of the domestic machine-building industry, indicating a transition from reliance on imported components to greater industrial self-reliance. When analyzing the statistics related to Russian locomotive production, it is important to recognize the methodology used for counting units. Electric locomotives are documented as complete locomotive sets, indicating that even if an engine consists of 2 or 3 interconnected sections functioning as a single operational unit, it is regarded as a single locomotive. This accounting approach accurately represents the operational reality of electric traction, wherein the physical configuration is determined by the type of service rather than the volume of production. In contrast, diesel locomotive production is documented on a sectional basis rather than by individual assembled locomotives. Because mainline diesel units in Russia are generally modular, with configurations varying from 1 to 3 sections based on their designated operational function, section-based accounting offers a more precise assessment of industrial output. A pair of sections, when assembled, makes a complete mainline locomotive, whereas industrial clients usually procure single-section models tailored for specialized applications such as mining or forestry. Meanwhile, shunting locomotives, commonly employed in yards and port terminals, are regularly manufactured as complete single-section units and are regarded as entire vehicles. This differentiation in counting methodologies is essential for comparing data across different years and for determining whether variations in production indicate a genuine decrease in demand or merely a change in product composition. During the first 9 months of 2025, Russian manufacturing facilities produced a total of 198 mainline electric locomotives. This figure includes freight locomotives used on heavy-haul routes, passenger locomotives employed on suburban or long-distance services, and multi-purpose models serving regional logistics hubs. The September output alone reached 30 units, a substantial figure that signifies increasing production intensity as the year advances. During the first 9 months of 2025, Russian manufacturing facilities produced a total of 198 mainline electric locomotives. This figure includes freight locomotives used on heavy-haul routes, passenger locomotives employed on suburban or long-distance services, and multi-purpose models serving regional logistics hubs. The September output alone reached 30 units, a substantial figure that signifies increasing production intensity as the year advances. During the first 9 months of 2025, Russian manufacturing facilities produced a total of 198 mainline electric locomotives. This figure includes freight locomotives used on heavy-haul routes. During the first 9 months of 2025, Russian manufacturing facilities produced a total of 198 mainline electric locomotives. This figure includes freight locomotives used on heavy-haul routes, passenger locomotives employed on suburban or long-distance services, and multi-purpose models serving regional logistics hubs. The September output alone reached 30 units, a substantial figure that signifies increasing production intensity as the year advances. During the first 9 months of 2025, Russian manufacturing facilities produced a total of 198 mainline electric locomotives. This figure includes freight locomotives used on heavy-haul routes, passenger locomotives employed on suburban or long-distance services, and multi-purpose models serving. From January to September 2025, Russian manufacturing facilities assembled a total of 182 diesel locomotive sections. Depending on the final configuration, this equates to approximately 90 to 100 complete locomotives when assembled into two-section units. Before 2022, the country generally manufactured between 250 and 350 diesel sections each year, resulting in the production of 120 to 160 locomotives. When compared to this baseline, the figures for 2025 situate current output firmly within the moderate historical range. Instead of indicating a decrease, this output reflects a planned realignment of traction balance, with electric locomotives progressively assuming primary responsibilities previously managed by diesel engines. The development originates from extensive electrification initiatives throughout Siberia, the Urals, and the Far Eastern regions, where infrastructure enhancements have been emphasized as integral components of Russia's national logistics and export strategy. Nevertheless, diesel traction remains of vital importance. Numerous resource extraction regions, such as coal and mineral mines in Kuzbas, logging routes in Karelia and the Northwest, and industrial corridors in Sakhalin and Yakutia, continue to rely on diesel engines due to severe climatic conditions and the absence of electrified rail infrastructure. Port terminals, timber yards, and yard operations also necessitate versatile diesel locomotives to support activities that benefit from decentralized power sources. The technological profile of new diesel designs highlights fuel efficiency and modularity. Revised models manufactured at Kolomna and Bryansk incorporate sophisticated control systems, enhanced turbocharged engines, and domestically developed transmissions. Furthermore, numerous locomotives are equipped with hybrid or low-emission systems appropriate for industrial clients. The consistent, demand-aligned level of production guarantees the sustainable utilization of industrial capacity without resulting in oversupply. During the first 3 quarters of 2025, Russia manufactured 128 shunting locomotives. The demand for this sector of the industry remains highly stable due to its direct alignment with industrial cycles, as opposed to fluctuations in long-distance transportation. Shunting locomotives are indispensable for repositioning railcars within yards, terminals, warehouses, and sidings. They constitute the fundamental basis of freight movement within facilities and terminals. The figures tally closely with the pre-2022 average annual production range of 150 to 220 units. Replacement cycles within industrial complexes, particularly in metallurgy and petrochemical facilities, guarantee a continuous demand for new units. Furthermore, the increase in container traffic at southern and eastern ports, along with the expanding logistics capacity of inland terminals, supports the production of new switcher locomotives. The dependability and regional accessibility of Russian-produced shunting models further reinforce their robust resilience within the domestic market. The most significant factor in Russia's rail manufacturing data is freight rolling stock. Between January and September 2025, Russian manufacturing facilities produced 41,500 freight railcars of various types, a figure nearing the peak of pre-sanctions output. Among these, gondola cars totaled 17,700 units, tank cars numbered 13,300, flat cars comprised 4,860 units, and hopper cars accounted for 2,900. This composition exemplifies the varied logistical requirements across numerous cargo sectors. Gondola cars continue to be essential for the transportation of bulk commodities, such as coal, iron ore, and construction materials. Tank vehicles facilitate the transportation of oil, refined petroleum products, and industrial chemicals, a category strengthened by increasing export volumes via southern and eastern routes. Flat cars are progressively used for container transport and large-scale industrial commodities, whereas hopper cars play a vital role in agricultural and fertilizer distribution. Between 2018 and 2021, Russia's annual production of freight cars fluctuated from 55,000 to 65,000 units. The current 9-month trend indicates that 2025 is projected to conclude the year with approximately 55,000 to 60,000 units, aligning with the upper boundary of this historical range. This consistency demonstrates the adaptive capacity of Russian rolling stock manufacturers to sustain production levels despite a reconfigured geopolitical and trade environment. Freight car manufacturing serves not merely as an indicator of industrial capacity, but also as a reflection of the comprehensive restructuring of Russian commerce and logistics. The reduction of rail freight connections with Europe has been offset by the growth of routes extending toward Asia and the Middle East. This covers increased cargo transit along the Trans-Eurasian corridors to China and Mongolia, the international north-south transport corridor linking Russia with Iran and India via the Caspian Sea, and southern routes leading to the Black Sea ports. These new corridors have driven significant investments in rail infrastructure, terminal upgrades, and fleet renewal. The growing use of containers in east-west trade has heightened the demand for specialized flat cars and container handling platforms, supported by collaborations between China and India. Likewise, the establishment of oil centers and petrochemical terminals along the Black Sea has led to an increase in tank car orders. These patterns show that Russia's changing export landscape and import substitution strategy closely align with the production of freight rail stock. One of the notable accomplishments of the 2025 production cycle is the sustained expansion of domestic component manufacturing. After Western suppliers left and imposed licensing restrictions, Russian companies increased the production of essential train parts, such as traction converters, bogie assemblies, wheels, and onboard electronic control modules. Plants in Tikhvin, Nizhny Tagil, Altai, and Udmurtia have expanded their metallurgical and mechanical capacities to fulfill the demand for freight car frames and casting components. And Nev has established localized manufacturing of high-power traction motors and semiconductor converters, while Ural Locomotives has integrated domestically sourced components into its new electric locomotive designs. This process consolidates industrial sovereignty and supports technological continuity throughout the sector. The government's industrial policy has facilitated this transformation through subsidies, preferential loans, and strategic procurement commitments by Russian railways. Consequently, employment within locomotive and freight car manufacturing regions remains steady, sustaining the livelihoods of skilled workers within the country's established machine-building hubs. With strong momentum across all primary categories of rolling stock, the final quarter of 2025 is anticipated to reaffirm these trends. Electric locomotive production is expected to reach approximately 250 to 260 units by the end of the year. Diesel section output is expected to stabilize between 230 and 250, while shunting locomotive manufacturing may conclude the year close to 170. Freight car assembly, based on current monthly output, is projected to exceed 55,000 units, reaffirming the industrial normalization achieved over the past 2 years. As infrastructure initiatives continue, particularly the expansion of the Eastern Polygon and the modernization of the Trans-Siberian route, the next phase of development may rely more on technological enhancement than on volume growth. Priorities include the digital synchronization of freight logistics, broader implementation of predictive maintenance systems, and the integration of composite materials in freight car manufacturing. In conclusion, the performance of the Russian railway engineering industry for the first 3 quarters of 2025 demonstrates a clear resurgence of stable development and structural transformation. Electric locomotives are being manufactured at historically high levels, reflecting the sustained significance of electrified freight and passenger routes. Diesel locomotive manufacturing has reached an optimal balance with regional demand, while shunting locomotives persist in serving industrial yards and terminals. Freight car production, which is a key indicator of cargo movement capacity, has returned to levels observed before 2022, illustrating that domestic demand and export-oriented logistics have effectively utilized existing production systems. Beyond mere statistics, these accomplishments exemplify that the rail sector continues to serve as a fundamental pillar of Russia's industrial and economic framework. It ensures uninterrupted transportation of goods across vast distances, sustains employment across heavy manufacturing centers, and supports the strategic reorientation of trade toward Asia, the Middle East, and the Global South. Despite ongoing external constraints, Russia's railway manufacturing sector continues to expand domestic technological capabilities and uphold the infrastructure essential to national logistics. With the final quarter still underway, 2025 stands as the year in which the railway sector firmly reasserted itself as a central driver of Russia's economic resilience and strategic autonomy. If you think the video was informative, please like, subscribe, and share. Please also take membership of the channel to encourage us